I see a lot of people teaching trigonometry with only triangles first, and while that's okay, the definitions sort of break once you get past angles of 90 degrees and above. I think this can cause confusion later when circles are introduced. In this video, I hope to clarify any confusion by introducing the functions from both perspectives, though admittedly I'll start with triangles. Now let's start with a quick rundown of the basic anatomy of a right triangle. Just know that the two sides that meet to create the right angle of the triangle are called legs, and the side opposite to the right angle is called the hypotenuse. Now let's focus on just one angle and get to the functions themselves. All trig functions are simply ratios of different sides of the triangle relative to a chosen angle, not the right angle. Let's take a look at sine. The sine of an angle is the ratio of the length of the side opposite of the angle over the hypotenuse of the triangle. Now that's a bit of a mouthful, so I've just labeled the opposite side L1 and the hypotenuse H so you can see what I mean. I want you to notice something here, and understanding this will make the circle stuff way easier to understand. This is simply a fraction, and so that means you can do something like finding the length of L1 easily just by multiplying both sides by H. Cosine is very similar, except instead of dividing the opposite side of the angle by the hypotenuse, you're dividing the length of the side adjacent to the chosen angle. The hypotenuse will also be adjacent to the angle, so be careful when looking at the sides. You can do the exact same thing here to find the length of L2. Tangent is the ratio of the opposite side over the adjacent side. But guess what? Look at the ugly fraction below. Tangent can also be written as sine over cosine. Alrighty, so here's where things get interesting. We're going to step aside before we move onwards with the trig functions to get a little knowledge that's required out of the way to make sure we're all on the same page. Imagine a circle with radius 1 centered on the origin of the coordinate plane. This is called the unit circle. Now, if you pick a point on any part of the circle, a little bit of geometry will tell you that the total distance from the origin to the point you've chosen is always going to be 1, as that's the radius. This is nice, but sometimes you'll want to know just the vertical distance from the x-axis, or just the horizontal distance from the y-axis to your point. If you draw those individual distances, well, look what we've got here. Notice the shape these distances create. That's cool, but we're going to look at this a little bit later. I want you to notice the angle from the horizontal axis to the radius line. The angle is 30 degrees, and if we increase this angle, the point we've chosen rotates about the path of the circle as expected. However, notice the vertical and horizontal distances from the axes as this angle increases and increases. Do you see a pattern? If not, that's okay. We'll get back to this later. Anyways, now let's look at the triangle formed by these different distances. We'll be looking at the angle between the radius line and the positive x-axis. This is called standard position. So, keeping in mind that the radius is 1, let's take a look at what that means for our trig functions. As we've stated earlier, sine is opposite over hypotenuse, and the hypotenuse here is 1, so that means the sine is just the length of the opposite side, or the vertical distance from the x-axis to the point on your circle. By the same logic, cosine is simply the length of the side adjacent to the angle, or the horizontal distance of your point on the circle from the y-axis, and tangent is opposite over adjacent, the sine over the cosine, or the slope of the radius line. Now, if we were to plot the sine on a graph as the function of an angle in standard position, we would start with an angle of 0, and so the sine at 0 degrees would simply be 0, because the vertical distance from the point at that angle is 0. But let's see what happens as the angle increases. Now let's do the same thing with cosine, except now we're tracking the horizontal distance from the center of the circle to our point. As for tangent, well, I don't have a good way to visualize that, but I promise I'll upload something as soon as I figure one out. In any case, here's what that looks like. Now you should have a pretty solid understanding of what the main three trig functions are and how they relate to circles and triangles. I hope you learned something.